Alright, yeah. What's going on? Late video. Unexpectedly, I had some, family come over for my birthday, so I was kind of busy all day, even though I didn't want to do anything but this, so yeah. I'll see how long I can do this for. Kind of tired, kind of not, so yeah, we'll go back to what we were doing. And if you remember, we finished off with this, just I guess learning exponents. Yeah, I guess they want us to learn math before we go to big O analysis and sorting algorithms and whatnot. So yeah, see what we got to do here. Exponents grow very large very quickly. Let's take a look at the example of them doing that in code assignment. While the influencers who use our platform are really great at taking selfies, most aren't super great at math. We need to write a tool that predicts an influencer's follower growth rate. Complete the give follower prediction function. Right? Fitness influencers follow count quadruples each month. Cosmetic influencers triple. All their influencers doubles. For example, if fitness influencer starts with 10 followers, then after 1 month they should have 40 followers. After 2 months they should have 160. So to the power of use a geometric sequence formula that's slightly modified for this problem. A1 times r to the power of n. Okay. Let's watch this video.
Say a company earns $100 in their first year of business, and then in the second year they earn $200, then $400, then $800, then $1,600, doubling every year. This growth pattern is an example of a geometric sequence.
X
Each
squared.
number in the sequence is calculated by multiplying the previous number by some fixed number, which we usually refer to as r. And in this case, of course, that fixed multiplier is 2. Let's take a look at another example. Let's say that we start with the number 3, first number in our sequence, and then r is 4. Well, the next number is 3 multiplied by 4, which is 12. Then we multiply by 4 again, getting 48. Then multiply by 4 again to get 192, and then again to
this
get
is different than
768. Now, of course, there's an actual
how-
formula for this math that we're doing. A sub n, which just means the number that we are trying to calculate, the spot in the sequence that we care about, is equal to a sub 1 multiplied by r raised to the n minus 1. A sub 1 just refers to the first item in the sequence. R is that common ratio, the multiplier. And again, n is just the index of the number that we're trying to find in the sequence. For example, let's say we're trying to find the 7th number in a sequence where the starting number is 100 and the common ratio or multiplier, r, is 3. We can just plug that into our formula. A sub 7, the 7th number in the sequence, is equal to 100 times 3 raised to the 7 minus 1, which of course is just 6. And because 3 to the 6th equals 729, 100 times 729 is just 72,900. So that's our 7th number.
Okay. Guess we're doing math here. So we know for example of fitness influencer. So I guess we're doing. I guess we're doing fitness influencer type. So basically, we're just doing the formula. And the number of months is n. Return follower count is it 8n? Yeah, AN. Fuck. Let's just say total is equal to
Sub 7, the seventh number in the sequence, is equal to 100.
Yeah, so follower count times r to the power of -1. R should be
times 3 raised to the n-1. A sub 1 just refers to the first item in the sequence. R is that common ratio, the multiplier. And again, n,
that has to be the number of months to the power fuck.
is just the index of the number that we're trying to find in the sequence. For example, let's say we're trying to find the 7th number in a sequence where the starting number is 100 and the common ratio or multiplier r.
Okay, that 100 is the follower count. Has to be. Because that'll move. Okay, keep going.
Is 3. We can just plug that into our formula. A sub 7, the 7th number in the sequence,
Right.
is equal to 100 times 3 raised to the...
What the fuck is influencer type though? Oh, hold up. Yeah, I'm wrong. This is gonna be no months. Months -1. This is gonna be influencer type. I'm pretty sure this is how it... My bad about the plane. No, wrong. Follower count. Yeah, that's how this is gonna be 8 times r to the power of n.
7 minus 1.
It's expecting 40. Number wants 1. Fitness. Quadruples. So it'll be 4. So 10. 10. Follower count. Times. Influencer type. Which is fitness. Man, I'm tripping, bro. You're okay. If influencer type is equal to fitness, fitness equals 4, then we'll do if influencer type is equal to fitness. Oh, I didn't delete this, sorry. Actual 10. 10 times. What the fuck you want me to do? Yeah, but that just doesn't work like that. Huh? I'm not getting the formula right. Follower count time. So 1 month. Bro, why is this gotta be so much fucking math, bro? Oh my god. I gotta run out water. If influencer type is equal to fitness, is equal to, hold up, if its type is equal to, yeah, see, now this is a fail. Cosmetic, yes, I know that's wrong. Let me just do this first. Let me get the formula right. So if it's 10 and fitness is 2, using the geometric sequence formula, bro, let me watch the video one more time.
3. We can just plug that we are trying to calculate, the spot in the sequence that we care about, is equal to a sub n, which just means the number that we are trying to calculate, the spot in the sequence that we care about, is equal to a sub 1 multiplied by r raised to the n minus 1. A sub 1 just refers to the first item in the sequence. R is that common ratio, the multiplier. And again, n is just the index of the number that we're trying to find in the sequence. For example, let's say we're trying to find the 7th number in a sequence where the starting number is 100 and the common ratio or multiplier, r, is 3. We can just plug that into our formula. A sub 7, the 7th number in the sequence, is equal to 100 times 3
obviously A of 7. So all you need to do is 100, which is, if we do follower count, and it has to be follower count, right? That's what makes sense. Then we do, see, fitness is what quadruples it. So what did we have before? Yeah, times fitness, but now the months. Yeah, the months. So if I do fitness to the power of months, pass. Oh, there you go. Okay. Now let's do Aleph. Aleph influencer type is equal to cosmetic is equal to, it triples, so that would be 3. And then we'll do total's the same thing, but this is gonna be cosmetic. And then we have else. I don't need to write all that shit because it doesn't matter. Else anything that's all influencers, so we'll do anything else is equal to 2. Boom. Anything else? Okay, cool. Submit. Boom. Alright, let's see a solution. I guess exactly the same thing, except you didn't even need to put a variable there. Honestly, I could have just put 4, 3, and 2. If you're here, and then if else, just return follower count. If someone looking at this, it's kind of hard for them to understand if you read it well. But when I look back at this code, it kind of makes sense, but it's longer and more tedious, if that makes sense. But I guess we'll just move on. Non-linear growth. Exponents are important to understand when it comes to execution speed of an algorithm. If the number of operations grows quickly as the amount of input data increases, the algorithm becomes slower and slower. Linear. 2 times 2 is 4. Quadratic. 4, 9, because you're multiplying by itself. Right? So exponents are important to understand when it comes to execution speed of an algorithm. If the number of operations grows quickly as the amount of input data increases, the algorithm will become slower and slower. Okay. So y to x squared, y to 2 times x. The doubling formula 2 times x results in linear or straight growth. The quadratic formula x squared keeps growing faster and faster. What does this have to do with code? Generally, we try to avoid writing code that causes the usage of resource to grow quadratically with an exponent. Sometimes there's a lot of computations, CPU utilization, slowness. Sometimes there's a lot of memory usage, RAM utilization. Sometimes there's a lot of large storage requirement takes place. A notable exception is in cryptography and security. We want to force attackers to waste resources trying to get information. I never knew about this. The result of which operation grows fastest. Multiplication, exponentiation, division, exponentation. How much larger is 2 to the power 64 to 2 to the power 32? Fuck, how am I supposed to know? So you multiply this by 2 times 2, 4, 2 times 2. It's not 2 times larger for sure. It gotta be 32 times. It has to be this one. Yeah. Alright. Logarithms. A logarithm is an inverse of an exponent. A logarithm is an inverse of an exponent. 2 to the 4 equals 16. Log 2 16 equals 4. Log 2 16 can be read as log base 2 of 16. It means the number of times 2 must be multiplied by itself to equal 16. The number of times 2 must be multiplied by 16 is 4. Log 12 might also be written as log 2 16. Some more examples. Log 2 to 2. To get to 1 is 2. To get to 2 is 2. 3. Okay, so what's the Python syntax? There isn't a language level operator to calculate a logarithm, but we can import the math library and use the math.log function. It's math.log 16 to logarithm base. Let's create a okay, let's watch this video.
A logarithm is the inverse operation of exponentiation, basically a backwards exponent. So we know that 2 to the third power, 2 times 2 times 2, is 8. And 2 to the fourth power, or 2 with a 4 exponent, is 2 times 2 times 2 times 2, which is 16. A logarithm is when the thing that we're calculating isn't the result of exponentiation, it's the exponent itself. In these examples, the 3 and the 4. For example, log base 2 of 8 is 3. Just like 2 raised to the 3 is 8. Log base 2 of 16 is 4, and log base 2 of 32 is 5. Now, in mathematical 16, 3. just like 2 raised to the 3 is 8. Log base 2 of 16 is 4, and log base 2 of 32 is 5. Now, in mathematical notation, log base 2, the base is typically written in subscript, of 16 equals 4. That's how we read it in English. And what log base 2 of 16 really means is, what I recommend you kind of think of it in your head as, is what's the power that I need to raise 2 to get the result of 16? And of course, in this case, the answer is 4. Now, the base doesn't have to be 2. In programming, it's really common for the base to be 2 because we work in binary. But we could also take log base 10 of 1000. And what do you think that is? Remember, the question is, what's the power that I need to raise 10 to get a result of 1000? Well, the answer is 3, because 10 to the third is 1000. Let's take a look at a bunch more examples. Log base 2 of 2 is 1. Log base 2 of 4 is 2. Log base 2 of 8 is 3. Log base 2 of 16 is 4. Log base 2 of 32 is 5. You get the idea. Log base 10 of 10 is 1. Log base 10 of 100 is 2. Log base 10 of 1000 is 3. And log base 10 of 10,000 is 4. So it's important to understand that exponents grow very quickly. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16, 2 to the 5 is 32, 2 to the 20th is 1,048,576. On the other hand, logarithms grow very slowly. Log base 2 of 2 is 1, log base 2 of 4 is 2, log base 2 of 8 is 3, log base 2 of 1,048,576 is just 20. And even more crazy, I'm gonna have to read this one off, log base 2 of 1,099,511,627,776 is 40. Now, because logarithms grow so slowly, they're really useful when it comes to coding and computer science. When we write a program that gets slower in exponential time, that means it's going to get really slow as its input size grows. But if our program only gets slower at a logarithmic rate as its input size grows, it's going to be a really fast program.
Okay. What do you want me to do? Okay, we read this already, so we already imported math. Let's create an influencer score. It will be a small number, like less than 100, that will give influencers a metric for comparing their social media success against their peers. Complete the get influencer score function. An influencer score is their average engagement percentage multiplied by log base 2 of their follower count. What does that mean? Return math.log and then we do the parentheses like less than 100. It will be a small number, like less than 100, that will give influencers a metric for comparing them. Okay, whatever. Complete the get influencer score. Yeah, function. Influencer score is their average engagement percentage, right? Multiplied by log base 2. So average engagement multiplied by by 2 of the number of followers. Oh shit. What is the issue here? Number of followers 4,000. Is this supposed to be? Still fail. There's something that's failing right here. Unsupported operator type 4. Oh. Okay. Floating set. This is a set? I hate this shit. Log base 2 to 4. Hold on. What was the number? 40,000. This has to be 2. Oh, okay, then times 0.3. .58 log base 2. There's a problem though. There's something that's not running right. Unsupported operator types for so float, which has to be this, and then a set. How is this a fucking set? Is their average engagement percentage multiplied by log base 2 of their follower count. Am I tripping? Does this have to be num followers times average? It's because these two just don't work together. Why? I don't know. Math.log. Oh no. This is average. 2. Still that, bro. Oh my god. $14 minus month divided. The error type, unsupported type is when you invert commas. So yeah, this is it will be okay. Less than 100. That will be given. Unsupported all parameter types. Integer and a set. Should I? Bow. Python ID. No. Not understanding what the issue is. If I go x is equal to type this. Oh. To set. And then if we do x is equal to, what was the thing? It was 0.3, I'm guessing. Average is 0.3. Doesn't make sense though. Complete the get influencer score function. An influencer score is their average. Okay, it's expecting 5, bro, but it's pissing me off, bro. Bro, like, what the fuck you want me to do, bro? Oh my god. You want me to do num followers times this, bro? Like, oh my god, it's pissing me off, bro. Bro, I'm getting pissed the fuck off, bro. Bro, I don't like doing what I'm doing right now. It's just like, bro, it's not. I get that it's a set. Swap the arguments. Okay, I'll swap the fucking arguments, bro. Bro, no way it's using F strings. So this whole time. Bro, what the fuck? Bro, it makes so much sense why they do that, because it's an F string. Without it, you don't need this stupid curly braces. It turns to a set. Forgive me. Forgive me, please. So we were right from the beginning. We were so right from the beginning. It was just this. Multiplied by log base 2, which was what was it, num followers. My fault, man. Jeez. I'm so stupid. Logarithmic exponents grow very quickly and logarithms grow very slowly. A logarithm is the inverse of an exponent. So, yes, the inverse of an exponent. It goes slowly. Exponents grow fastly. Generally speaking, it's nice when we can write code that is log n time to run, where n is the amount of data processed. For example, let's say we have a list of a million users and we want to use that finds a user with the most followers. It takes 1 millisecond to check one user. Let's just pretend a linear algorithm would take 1 million milliseconds, which is 16 milliseconds. A quadratic algorithm, holy shit, a trillion. So input size 10, that's 10, that's 20, sorry. So log, that's nice. Nice. Power is horrible. Linear, quadratic. So the worst is quadratic. Linear. Oh, I'm tripping. Yeah, quadratic is the worst. Linear is the second worst. Damn, log 2, that's pretty good, no? This would be 3. Wait. 2. Sorry. No. This would be 1. This would be 25. The result of which operation grows slowest? Logarithm. Factorials. We're almost done with the math that you'll need for this course. Just one last thing, factorials. The factorial of a positive integer n, written n factorial. Yeah, I know this. It's gonna be 5 times 4 times 3 times 2 times 1. Yeah, 120. The results of factorial grow even faster than exponentation. Grow even faster. So 2, that'd be 4, 6, 8. How? 6 times 5. Oh no, I'm tripping. So 3 factorial 6. 3 times 2 times 1. 4 times 24. Yeah. So factorial is the worst then. Holy shit. Influencers need to be able to schedule posts to be published in the future. We found that the order in which posts are published are... Oh, assignment. So, okay. Assignment. Need to be able to schedule posts to be published in the future. We found that the order in which the posts are published drastically affects their performance. Complete the num_possible function, right? This one. It takes the number of posts on influencer. It takes a number of posts an influencer has in their backlog as input, and returns the total number of possible orders in which way they can publish the post. Okay. So I mean, there's like there's a way in my head that I could do it. It's like x equals, let's just say, going down is equal to num post, and then we'll do x, so the total is equal to 0. So 4 doesn't work like that. I'm gonna try something. Oh my god, why do you do that? For num in num. I want to see if this works. Probably not. Yeah. How can I go down? What was I trying to do? I was trying to go through 52. Then we do 52 times. I don't know what I was thinking. Is there some type of like formula where I could do return to numpos like formula? I have no idea what the fucking formula is. Bro, how do I decrease it? I don't know how to decrease it. What? I don't know how to decrease num post whenever you multiply. Oh, while loop. Oh shit, I'm tripping. I haven't done a while loop in a minute, that's why. While n is less than num underscore post plus 1. Wait, okay, so if it's num post, if it's 52, it'll stop when, well, n is less than or equal to, I don't even need these parentheses, num post, while n is less than, we want to do, let's just say x is equal to 0, we're gonna do x, let's just say x equals, wait, what the fuck am I doing? while n is less than numpos. It's not clicking me. So if I do while n is less than numpos, let's just say it's 5. I kind of want to do this over here so I can have some room. Oh, sorry. So while n, so let's say numpos is 5, numpos is equal to 5. We want to do 1. That's not how it works. It has to be a while loop, because well, n is less than or equal to numpos. We're gonna do, I guess, I don't know, numpos times post minus n, and then we'll return x. Fuck is all print. And it's not defined. It isn't. It isn't. Look, I need a hint. I'm stuck. Is a loop even necessary for this calculation? Okay, so he's saying that the loop is not even necessary. So if I for factorials, you're like a, can I just import math? Permutation. Oh, this formula. is related to it. It's not it, but I so remember this from stats. Fuck that shit. I don't know. It's like I don't know what to do. Num fucking post minus no, sorry, times num post -1. It just keeps going and going and going. I don't know. It's not clicking in my head. Think about this. If you have 3 posts, how many can you rearrange them? A, B, C, A, B, A, C, B. Yeah, I get that. Bro, what the fuck? A factorial? You want me to use a built-in function? For a question, younger, so we know that the factorial of a number n, the product of n down to 1, for example, 4 power 4, right, given numpos, how might you multiply all numbers from numpos down? So I was right, kinda? Cause like, if I do, say, x is equal to wow numpos is wow numpos, see if the 52 is less, if it's less than while numpos 52 is I think I got it. If numpos does not equal I don't know if this is right. This is probably running a wall. Okay. Oh my god. Well, okay, let's look at the code that I just made. While numPost 5 does not equal 1, 5 times 4 is 20, and y is equal to 4. Then we go back. numPost is 4. So 4 times. How does this not work? How does this not work? How does this not work? I need a hint. I'm not seeing it and I'm fucking sleepy. What the fuck is juice here? Right now your loop is not really looping. You're updating variables but aren't reducing numPost properly inside the loop. And you're restarting the multiplication every time instead of building on it. Think about how to keep multiplying the results as you go and make sure the loop actually progresses. numPost times fuck, bro. I don't know. Stupid. This is not even fucking like algorithms, bro. I'm just trying to learn how to use fucking n square and factorial, bro. Oh my god. Y equals numPost minus 1. Should this be inside the loop? Cause if it's outside, no, this would not work. I'm gonna take a L on this one, bro. Damn. So easy. Fuck. Well, num post is greater than 1. X, so kind of the same, but I wasn't formatting it right. Damn. Even if I don't even like the while loop, this range one makes way more sense to me. Damn. Damn. Whoa. Damn. Took an L on that one. Factorial quiz. Again, the factorial of a positive integer n written n factorial is the product of all positive integers less than or equal to n. Yeah, so 5 times 4 times 3. So n squared. So we put n. God damn. Holy shit, it just goes. How much larger is... Yeah. Which grows the fastest as n increases? Alright, let's finish this, and then this, and then, I will call this a successful day, even though I wish I can do more. Let's see what this is. Let's keep going. Take some water. I promise we'll get to know the... What the fuck is going on? In physics? In physics, exponential decay is approximately... And locked into tend to lose followers. So the more followers you have, the faster you lose them. The complete the decay followers function. It calculates the final quantity after. It calculates the final value. Wait, hold up. So okay, all I know right now is that it's difficult down, bro. I'm so gassed. Complete the decay followers function. It calculates the final value of quantity after a certain time has passed. Given its initial value and a rate of decay, return the remaining followers. So remaining total is quantity, retention rate to the power of time. Example. Okay. Initial followers to the power of the rate, which is the fraction lost daily, to the power of days. Oh, sorry. We're multiplying, right? Yeah, we are. Oh, we have a fail. What's the fail? Actual 0. What? We have multiple fails. Fuckers. So our initial followers and how much we lost daily and the days. Complete the decay false function. It calculates the final value of a quantity after a certain time has passed given its initial value. Return the remaining followers. Remaining total equals quantity. The retention rate. The retention rate is the opposite of fraction lost daily. It's an influencer's lost 0.2. Yeah, the retention rate would be 0.8 or 80%. With the parameters. So initial followers is 100. The fraction lost daily is 0.5. So for range. What am I doing? Followers. $200. Dude, this is a bunch of fucking math, bro. I'm losing my fucking mind, bro. I'm not even learning algorithms, I'm learning fucking math, bro. I'm learning fucking math. Exponential decay. So 100, 100, 200 should be I see. So when it's 100 followers, why am I doing 0.5? Was I doing 0.5 this whole time? Bro, my bad. I'm fried. I literally can't even do this right now. I'm not even thinking. I think. Because it's not changing. How is this feeling? How am I getting fucking 0? Days is 3. Initial followers is 200 times fraction loss daily. No, the house in the middle. I don't know. Recalculating x from the original. Oh, so you're raising fraction. I need to wash my face or something, bro. You're recalculating x from the original initial followers instead of using the updated x from the previous day. Also, you're raising the fraction days inside the loop, which defeats the purpose. Nah, but I'm so fucking tired, bro. Also, you're raising the fraction lost daily to days. Oh. Have the num. No. The num is what the days or something. Ask yourself, should x be compounded each day? Yeah, x should be compounded each day. Oh fucking god, I'm losing my mind, bro. Like it. What? Final equals. I did that. That's not, bro, this is the most bullshitted shit ever, bro. I swear to God, bro. I hate doing math, bro. It doesn't give you like a proper. Retention rate. I don't get it, bro. I'm so tired. I'm gonna look over this tomorrow, see if I can understand it tomorrow. I guess it's 1 minus the fraction loss daily. Why though? Because it's going down by the days. Minus 0.5. 1 minus 0.5. Next one should be 0.2. 0.5 times 2 to the power 2. So, oh my god. My bad, guys. I'm so tired. I'm not thinking right. I think that's it for today. I'm gonna try to get some good sleep so tomorrow I can work a little bit harder. I'm sorry for not thinking well. I'll try better tomorrow. I'm sorry. Thank you if you stayed this long. I hope you enjoyed me suffering. And this camera never flipping works. Alright. Thank you guys for tuning in. Have a good one. Oh, and it's day 8. So, yeah. Thank you guys.